continuous integration, that's not what they meant. So maybe we better start by defining what we mean by continuous integration, because that's kind of the core of the whole talk, really. And you can tell by the title that I'm going to suggest that the current understanding of continuous integration might not match the original definition. So I'll start with what I think continuous integration is. So I'd like to invite everybody to stand up. Now, stay standing if at your company or in your team you do continuous integration. Okay, I've got a lot of people, cool. Stay standing if everyone on your team commits and pushes to a shared main source code branch at least daily. Okay. Stay standing if every one of those commits causes an automated build and test. Cool. Oh no, right, okay, lost a few more. Stay standing if when the build fails, it's usually back to green within 10 minutes. Oh well, never mind. Okay, so that was Jez Humble's continuous integration test. And Martin Fowler jokes about it on his website. He says that you can get certification if you pass, if you can answer yes to all of those questions. And what Martin Fowler is saying is that continuous integration happens when every developer commits at least daily to the shared main branch, that every commit triggers an automated build and test, and that when builds and tests fail, it's repaired within 10 minutes. Because that is continuous integration. That is where the code is being integrated with all the other bits of the code continuously. Now, typically, when people talk about continuous integration these days, what they mean is we are continuously pushing to our branches, and our branches are triggering quite often automated builds and tests. And we may even be regularly pulling from the main branch into our branch, but we are not integrating with every other developer's code continuously. And that is what Kent Beck originally meant when he first defined the term continuous integration. And he said in his book, Extreme Programming Explained in 1999, no code sits unintegrated for more than a couple of hours. At the end of every development episode, the code is integrated with the latest release. And this is the they that I meant when I said that's not what they meant. I'm talking about, people who first defined the term continuous integration, which is mainly Kent Beck and then a whole bunch of other people who were involved in extreme programming, as they called it at the time. It's worth me just talking a little bit about the difference between continuous integration and continuous delivery or deployment. Some people draw a distinction between delivery and deployment. Some people don't. But there definitely is a difference between continuous integration and continuous delivery. So when I say continuous integration, what I mean is that your code is being integrated with the rest of the code base on a continuous basis. When I talk about continuous delivery, I mean that continuous integration goes all the way to production. And that code is being delivered to users continuously. So every time the code is integrated, it then goes further through a pipeline to the users. I'm not talking about that today. I'm not talking about continuous delivery. I'm talking about continuous integration. Now, for me, a big reason for why you might want continuous integration is because you want continuous delivery. I'm a big fan of continuous delivery. I think it's great. It's just not what I'm talking about today. I'm talking about continuous integration. So I'm talking about what happens to your code and how your code is integrated with the rest of the code base. So you may have heard the term trunk-based development. And trunk-based development is a term that people use when they say that all of the code that is written in trunk, which is actually not a term that most people use anymore. So when I say trunk, I mean the main branch, the main line. And trunk-based development is where everybody is developing in the main branch, and they're just constantly pushing what they've done to the remote version of the main branch. So they're constantly integrating their code with their colleagues' code. And that is what Kent Beck originally meant when he talked about continuous integration. But because people don't tend to mean that when they say continuous integration, I'm going to use the term trunk-based development to make it very clear what I'm talking about. I really like the term trunk-based development because it does what it says on the tin. It very clearly describes what it means. Martin Fowler doesn't like it because he doesn't like semantic diffusion. He doesn't like it when terms lose their original meaning, and he thinks, out of respect to Kent Beck, we should continue calling it continuous integration because that's what Kent Beck meant. I talk about trunk-based development just so that it's absolutely clear what I mean. And I think that trunk-based development makes things better, faster, and happier. So I think that it leads to better quality code. I think it leads to faster delivery, and I think it leads to happier developers. Happier because better and faster means more satisfaction, but also because trunk-based development facilitates and necessitates much better communication and closer collaboration. And that can lead to a much happier team. But I'm not the boss of you. So I am not here to tell you that you should all be doing trunk-based development and that you're bad people if you're not. I'm not here to slag people off, and I'm not here to tell you what to do. I'm just going to make the argument that trunk-based development is a good idea. I'm not saying you have to do it. And this is a topic that people get surprisingly aerated about. I have been accused in the past of saying that if you're not doing trunk-based development, you're not doing continuous integration. And I guess I am saying that because I'm saying that continuous integration and trunk-based development should be synonymous. But I get it. People don't like being told that they're doing it wrong. And I'm not saying you're doing it wrong. I'm just saying that trunk-based development is something that's seriously worth considering because it can make really positive differences. But there are lots of reasons why people aren't doing trunk-based development, and I get it. And there are lots and lots of factors that influence how any one team does software development. And trunk-based development is not a thing that you can just do. You can't just go back to your teams and say, I've seen this talk by Claire Sudbery and I've decided we're ditching all our branches and we're going to do trunk-based development from now on. It requires a certain set of skills and practices. And they might not be skills and practices that your team are used to using. So I'm going to talk through what those skills and practices are. I'm going to talk through the different things that you would need to have in place in order to be able to successfully do trunk-based development. And I can also talk you through a kind of step-by-step process of things that you could do that would bring you closer to trunk-based development, even if that's not your goal. There are lots of things that you can do that will improve your software development and delivery, and ultimately you might end up doing trunk-based development. I think that's a great idea, but I'm not the boss of you. And moving in that direction is a good thing, even if that's not your goal. So, branches. Branches can slow you down and increase risk, and this is core to my reason for preferring trunk-based development. So let me explain. And I'm going to explain by telling you a story. Because I like telling stories, and I am, in fact, also a novelist. So telling stories is my thing. And stories are really useful. They're a really useful way of explaining things and learning about things. And in order to tell you this story, I'm going to use some basic storytelling principles. That if anybody saw the Ignite talks last night, this is the same slide. I mentioned this book last night as well. This is called Story. It's by Robert McKee, and it's about how to write compelling stories. He actually wrote it for screenwriters, but it also works for novelists. It's just about how to tell good stories. And one of his core principles is that in each discrete chunk of your overall story, so in the case of screenwriters, that's a scene. In the case of novelists, that's probably a chapter. In each section of your overall story, your protagonist, your main character, will start in a particular state, and then there should be a turning point in the middle somewhere where something crucial happens and something changes, so that when you get to the end of the scene, the end of the chapter, you are not in the same state, your protagonist is not in the same state as they were at the beginning. Something has happened. Something is driving the story forward and keeping the audience interested. I'm going to use that principle, the idea of a start state, a turning point, and a new state, to tell you a little story. I'm going to describe a fictional team. They don't exist. I've invented a team for the purpose of illustration. But I'm going to describe this fictional team and their journey towards trunk-based development. So, and every slide is going to have the same structure where you've got start state, turning point, end state. Now, our fictional team are new. They've only just started working together. They've maybe been working together for a few weeks. And so far, they've been working in branches because that's what they're used to, and it's what they've always done wherever they've worked before. But one of them has seen, maybe they read my article, or maybe they've seen one of my talks, or maybe they've seen somebody else talking about it. But they've decided that trunk-based development is a really good idea. Oh, sorry, I forgot the turning point. The turning point is they're working in branches, but they're constantly experiencing merge hell. So every time somebody finishes work in a branch and tries to merge it back into the main line, merge hell, and it's causing a lot of problems, and they hate it, and they've heard about trunk-based development, and apparently you don't get merge hell when you do trunk-based development. So yes, we're all going to do trunk-based development from now on. No more branches. So this is our end state. We're now doing trunk-based development. So we start with trunk-based development, but then somebody comes along and says, no, you can't do that. Like, it's not compliant with the regulatory conditions that we're working under. So there are various standards such as HIPAA, SOC 2, ISO 27001. There are various standards that people will say mean that you have to work in branches because you have to have pull requests, and you can't just go straight into the main line. You can't just be having code that just goes straight into production. So they're like, oh, okay, right, then we better go back to branches then, and we'll have pull requests and we'll have code reviews, and that's how we'll be able to demonstrate that there's some kind of quality control to what happens to this code that's been written in these branches. This is how we'll be able to demonstrate that more than one person is looking at this code, that this code is being checked before we allow it into our main code base. So now we're back again to branches, PRs, code reviews. There is a problem, though, with this, because it assumes that your work has to be checked. Its starting point is your work might not be fit for purpose, and we really need to get somebody else to check it before we can allow it back into the main code base. And this implies a lack of trust. It also means that because we're now in a kind of default where we're thinking, well, we're not sure if this code is okay, we end up with even more pull requests and even more checks and balances, which leads to even less trust. But it also means that we're moving quite slowly, because every time I finish a piece of work, I now have to wait for somebody to be available to review my pull request. And they're not always available. They're busy, and they're thinking about other things. I'm now asking them to context switch and come and look at my code that they don't necessarily know very much about. They've got to try and get their head into what I'm doing. It's going to take them time, and it's going to take time before they're available. So there's even more delay now before each bit of code gets to find its way back into the main code base. So we're moving quite slowly. Now, this is where I get on my high horse a bit about pull requests. And what I actually did, so I used to work for ThoughtWorks, the consultancy, and I'm still on a couple of Slack groups with the people who are there or who used to work there. And I just asked them, what do people think about PRs? And I got a deluge of responses. People who hate PRs, hate code reviews. So Dan Abel said, PR feedback is the last point in the development cycle where feedback is useful and often the most wasteful. So the thing is that you're working on a new feature, for instance. There's a lot of work associated with that. You've had to get your head around a bunch of things. You've had to make a lot of decisions. You've maybe changed the way the code is organized. You've done a bunch of stuff, and you've made a lot of decisions. And then when you've finished, then you get feedback. And at this point, if you've made decisions, if you've committed, if you've put a lot of work into something that actually maybe wasn't the best solution, or maybe there was something else in the code base or the domain that you didn't know about that mean that this is actually not the best approach, it's a lot harder to get that feedback when you've finished the work than it is while you're doing the work. And there are all sorts of other things to do with like coding standards and the way the code is organized, mistakes you might have made, all of those things you would have been better off knowing about it while you were doing it rather than when you finished. And there's also an incentive for people to actually say, oh, well, it's too late now. I'm not going to make you rewrite it. And so it goes in anyway. Another quote that I got was, this was from Keith Morris. This is actually from his book, but he was also in the Slack group and he did have things to say, but I think I got this from his book on infrastructure as code. Using pull requests for code changes by your own team members is like having your family members go through an airport security checkpoint to enter your home. It's a costly solution to a different problem. And I think one of the things that he's referring to here is the origin of pull requests. So the idea of pull requests and branches, part of its origin story was to do with open source development. Now, if you're doing open source, people are contributing to your code base who you know nothing about. So it absolutely makes sense that there would be checks and balances and that you would ask them to issue a pull request and you would check what they're contributing quite carefully before you merge it into your code base. But if you're working with a team of developers that are your colleagues and you're working together on a daily basis, that is a very different situation. So there was a great talk that I saw by Dragan Stepanovic at New Crafts in Paris last year. And he did a whole piece of research about pull requests. And he measured a lot of metrics to do with how often people issue pull requests, how they're treated, what kind of responses people get to them, how long it takes people to review pull requests. And one of the things he said was that the bigger the pull request, the more likely it will suffer from the so-called looks good to me syndrome. If the PR is big, reviewers have way less incentive to build in the quality. Because if there's a lot of code, you've got to spend time looking at it. You've got to context switch to understand it. And like I said before, you potentially got to suggest that somebody's making major changes. And you're not going to want to do that. So the more code there is, the more likely is people just, oh yeah, it's probably fine. And what Dave Farley says is that his experience across the board has been that regulators prefer truck-based development and genuine continuous delivery once they come to understand them, because they provide a better quality experience all round. So when people say we have to have branches and pull requests because compliance, when you dig into it, that's not actually what the regulations say. What the regulations say is that they want some way of knowing what changes are being made and what impact they have. They don't say how you should do that. And the thing about continuous integration with a robust pipeline with automated tests is that you have got a very strong audit trail. You've got a very strong track of what causes problems and what doesn't. And you're also saying that nothing gets to production without going through a series of checks. And auditors love that. So Dave Farley also says the more complex the compliant mechanisms around change, the lower the quality of the software. Because of what I said before, that what you're doing is if you're putting checks and balances in place, what you're actually saying is we are delaying the integration of this stuff. We're putting blockers in the way of getting this stuff into the code base, which might sound safe, but it isn't, because you're increasing risk. Because the longer it takes for code to get back into the made code base and get into production, the more likely it is that there will be problems with it, because it's integrating with code that wasn't known about at the time the code was written. Also, the problems are, the bigger the PR, the bigger the branch, the bigger the problems, because the more chance there is that there's changes, the bigger those and the bigger those problems are likely to be, and the harder it is to track them and fix them. With continuous integration, you only have tiny changes and tiny risk as a result. So what he says is that he believes it's not possible to implement a genuinely compliant regulated system in the absence of continuous delivery. So he was also talking about continuous integration. I'll link to that article at the end. But that doesn't mean that you don't have code reviews. So I think that code reviews are problematic in lots of reasons. So I've talked about some of them. I've talked about the context switching. I've talked about the difficulty in finding somebody's time. I've talked about the tendency to say, looks good to me. And ironically, the flip side of that is the smaller the PR, the more likely people are to pick nits. But it ends up being nitpicking. And part of the problem can be that somebody feels like, well, if they haven't picked nits, they haven't done their job. So you give them a pull request or a code review and they're like, well, I'm supposed to find things wrong with this, which again lowers trust and increases conflict for no good reason. But doesn't mean that you shouldn't review each other's code. Now, the best way of reviewing each other's code is to pair, so that you're right next to each other, you're writing the code together and you're seeing the code that's being written at the time that it's being written. And there's always two pairs of eyes on any piece of code. But in the absence of that, you can do code reviews of the whole code base or of targeted areas of the code base at regular intervals as a team. So, for instance, if I'm in a team where they are doing code reviews, then I will nearly always say, if somebody says, right, I've got a pull request here, I'd like you to do a code review, I'd say, great, come and join me. Talk me through what you did. Tell me about it, because that's going to be a much better way for me to understand it, is for you to explain it to me. But it also means that you get the rubber duck syndrome. So quite often somebody will describe something to me and explain it to me. And as they're describing it, they'll go, oh, yeah, but I actually could have, and hang on a minute. And they spot problems before I do. But just having somebody to talk to about it and doing it collaboratively is a much better way of doing code reviews. But for that reason, what you can also do is simply get together as a team on a regular basis and review new features, review new bits of code, talk about it together, explain it to each other, have a conversation. So yeah, the feedback those code reviews don't have to happen at only that one point in time, at the point of a pull request. So anyway, back to our fictional team. There's been this explosion of PRs and code reviews. They're moving really slowly. It's really hard for them to get to the code reviews and the PRs when they need to. This trust has developed, this culture has developed where they kind of tend to pick nits in each other's code. And somebody sees yet another article or a talk about trunk-based development, and they say, I saw this thing, we should just do trunk-based development. So they say, right, that's it. All branches being dropped. We're going back to trunk-based development from tomorrow. Trunk-based development all the way. Now, this is what I'm calling big bang trunk-based development, because again, it's being done suddenly and without any preparation. And they're not necessarily in a state where trunk-based development is going to work for them. The first problem that they come up against is that they don't actually have an automated suite of tests on this code base. So trunk-based development is all very well, but they can't deploy it because the only testing regime they have is a manual testing regime. So they have to wait for the code to be tested before it can be deployed. So now they're doing trunk-based development, but with manual testing, because that's fine, because like I said, continuous deployment is not the same as continuous integration. So the code is being integrated continuously, but then it has to wait for manual tests before it can be deployed. But then they get bored of that and they get impatient, and somebody needs something deployed urgently to production. So they just deploy it anyway without testing it. And now there's a massive system failure. It's all gone horribly wrong, and everybody's pointing fingers of blame at each other. They are unhappy. Blame leads to guilt and shame, which are not productive emotions. So everybody's pointing fingers at everybody else. Everybody's feeling guilty and worried and saying, oh no, it was my fault. And at this point, they recognize that they have, major problems in the team. So they get help. Now, this is a blatant plug for the Saman technical coaching method, which is the technical coaching method that I use. It was conceived of by Emily Bache, who founded the Saman Technical Coaching Society, and she wrote this book, Technical Agile Coaching, which is all about how to do technical agile coaching. And what I'm suggesting at this point is that some teams do need help to improve their software development practices. It doesn't have to be an external coach. You can have technical coaches that are internal to companies. You can build up technical coaching skills from within. But in order to be successful, as Emily says, in modern software development, software developers need new skills. And the skills that you need in order to be able to successfully do continuous integration are not skills that all software engineers have. And they're not easily learned on a short training course either. They're best learned hands-on on an actual code base. And the way the Saman technical coaching method involves working with people on their actual code bases to help them to improve. But practices like continuous integration and test-driven development require developers to change their minute-by-minute habits and ways of working. So that minute-by-minute thing, you may have been thinking, how is any of this working? How are you able to integrate so quickly? So a lot of developers are used to working in branches in such a way that somebody gives me a feature to write, and I go away and write my feature. And in order to write my feature, I have to kind of pull the code base apart a bit. I have to rearrange the relationships between some classes. I have to add some new classes. I'm maybe going to change some of the dependencies. And in the meantime, it's all broken. So I mean, it's not working, but I don't mind because I'm in a branch and I'm safe. That's my nice safe space. So it's okay. How could I keep integrating every couple of hours or even every few minutes? How could that be possible? It is possible, but it requires you to work in a different way. So it requires you to learn how to make tiny changes to your code base and then push those changes. And I'll talk a bit more about that later. But this minute-by-minute habits are what you need to build up in order to be able to really do continuous integration. And Kent Beck wrote the foreword for Emily's book. He says that software development is best seen as a learning process where running programs are the proof of learning rather than a factory or production process. So walking a new path together along with an experienced guide reduces time spent not learning because of fear. And this is another thing that I like to talk about, is how software development is a process of learning, continuous learning. You can't get away from it. I think sometimes, because I do a lot of teaching and coaching, and I do a lot of training, and sometimes new developers think that they're just going to learn a bunch of stuff, and then one day they'll have learnt it, and then they'll know all the things, like all of those people around them. They know all the things, right? And once you know all the things, then it all gets easy. You're never going to know all the things. Even if you could possibly fit all of the things in your brain, which you can't because there are too many of them, but even if you could, by the time you've learned them, new things will have come along. And it's almost impossible. I mean, some people do manage it, but it's very difficult to only ever code in one language or framework or technology as well. Chances are, during the course of your career, you're going to encounter new languages, new technologies, new tools, new frameworks, and you're going to have to learn them. And if you embrace learning, then that makes everything much better. And if you see learning as being the point of it all, then it all gets a lot easier. Okay, so the team has now acquired a coach. Maybe it's an internal coach from elsewhere in the company. Maybe they've hired a freelance technical coach, but they've now got a coach, and the coach is helping them to learn pairing and ensemble work. So this is where they're not working on their own anymore. They're working together on code, sometimes in pairs, sometimes as a whole team. And in the process of that working, they're also learning how to get really good at test-driven development, refactoring, and automated testing. I've kind of thrown them all on one slide. Those are three really big things. So test-driven development, I think, goes very, very well with continuous integration. I think you could probably get away without doing test-driven development as long as you have a decent suite of tests. But if you're going to have a really good suite of tests, in my experience, the best way of doing that is to write the tests first. It's also extremely useful when you're working in these tiny chunks. So every little bit of code you write starts with a test, and then you make the test pass. And those tests are as granular as possible. So the amount of code you need to write to make the test pass is very small. But the thing is that now you've got code that compiles and that makes the tests pass. So it can be integrated with the rest of the code base. Obviously, you learn how to isolate code in progress, but that's really not that difficult. You can have classes that are not yet being used by the rest of the code base, but are making test pass and compile. And then automated testing. Again, you get that for free with test-driven development because you've already got the tests. I mean, you're going to get totally for free because you've got to build them into a pipeline. You've got to make sure that you can automate them, but that's not generally so difficult once you've got the tests there in the first place. But refactoring is another really core skill that a lot of developers struggle with. And again, there is more than one way of doing refactoring. A lot of people think, so a lot of people have somewhere in their backlog at least one ticket that says refactor that bit of the code base. And what they're imagining is that this is going to be a major piece of work. It's going to take like days or weeks. We're going to drop everything and we're going to refactor this thing. And in the process, we're going to break everything. So it's going to be like fixing the car engine where you take it completely to pieces and all the pieces are lying on the floor. And while you're in the midst of that, nothing gets integrated with anything. That's one way of doing refactoring, but it's not the best way of doing refactoring. It is possible to learn how to refactor in tiny chunks. You just make one small improvement, your tests pass, your code compiles, it can be integrated with the rest of the code base. That is a much better way of doing refactoring, but it's a skill that can be learned. So we've done all of this, but we were still, remember, we've been on this journey for a while now, and we've still got a lot of legacy code that maybe wasn't brilliantly written and is really quite tightly coupled, which means that our builds are slow. So it's all very well saying we're doing continuous integration, but every time somebody integrates, which is now happening several times a day, the build takes forever. And ideally, you want to wait for the build and you want to wait for the test to pass to make sure you haven't broken anything before you go on to your next piece of work. Well, you're not going to want to do that if your builds are really slow. So in this team, their builds are really slow. So they minimize their dependencies. They refactor the code to minimize dependencies and speed the builds up. Because you can have incremental builds that will only build what needs to be built. But if it's really tightly coupled, then one small change affects the whole code base. So we've minimized dependencies. And now, let's just talk a little bit about that. So this is about improving your code base in order to make sure you can have fast, efficient builds. And that's something that you have to keep thinking about. You have to keep thinking about your dependencies. And as they say in the book, Accelerate, continuous integration requires relentless work to simplify systems architecture on an ongoing basis to ensure that this automation isn't prohibitively expensive to create and maintain. So automated builds and tests don't work so well on some code bases. Sometimes you have to improve the code base in order to make that work. And if you haven't come across the Accelerate book, it's a fantastic book. It came out of the DORA reports, which are published annually and have been since 2014. DORA stands for DevOps Research and Assessment. And the State of DevOps reports are published once a year. And it is arguably the most scientifically rigorous set of research ever published in the area of effective software delivery. And the DORA founders, Nicole Forsgren, Gene Kim and Jez Humble, who I mentioned earlier, he came up with the continuous integration test that I made you all stand up for. They expand on their methodologies and recommendations in the book Accelerate. So the methodologies and recommendations that come out of the DORA reports are summarized in the Accelerate book. And the Accelerate book absolutely emphasizes the importance of continuous integration and trunk-based development. And that's also been a conclusion of pretty much every DORA report as well. So they've now minimized their dependencies, but just because you've minimized dependencies doesn't mean your tests are in good shape. They've now got loads of modules and they've got like a lot of tests that aren't necessarily needed, but their tests are now quite slow. So they refactor their tests because that's another thing that's a really good idea. So now their tests are faster and they're incremental, by which I mean that in the pipeline, and on a continuous basis. So there are various tools you can have running in the background. I Sorry, I work in .NET quite a lot. And I use a tool called NCrunch, but IntelliJ has also got its own built-in tools that run the tests for you continuously in the background. You don't even have to say run tests, they're just running. And they're incremental, so it's not running every single test every time you commit a line of code. It's very clever. It can work out which bits of code are impacted by the code that you've just written, and it only runs those tests, which speeds things up. So that idea of incremental tests speeds everything up. Because if you have slow tests, then what happens is people don't run them. And they don't want to do continuous integration. But if they do continuous integration, they'll cut a few corners. So really, what you want to do is every time you make a change, you run the test, you make sure that they're passing, and then you commit back to the main line. But if your tests are really slow, that's just excruciating. And it means you're constantly either waiting for tests to run or just carrying on with the code anyway and just like hoping that those tests aren't going to fail, because if they are, you're going to have to go back and so slow tests have a massive impact on whether people will want to do continuous integration and whether they can do it effectively. So they've now got faster tests that are running incrementally, and it's all going quite smoothly, and it's they're in a rhythm. Like I write some code, I make some tests pass, and then I merge it into the main line. And people have got a bit lazy and they've stopped running the tests locally because they know there's a pipeline running over there and there's tests running over there, and I'm just it's fine. They're just pushing the code to the main line. They're not running tests locally. I'm not going to go into the details, but there are various reasons why tests might pass remotely but fail locally. And actually, it's that local failure that's giving you really useful information. Or the other way around, actually. But if you're not running tests locally, you are potentially causing problems. So what's happening is that the build keeps breaking. So people now get into the habit, they agree as a team, okay, we're going to make sure that we always run our tests locally, and we're also going to make sure that we keep the build green. But now, I said at the beginning that I prefer the term trunk-based development to continuous integration because it does what it says on the tin. And trunk-based development is continuous integration. It was the claim that I made. Well, it's not actually. Because if you have got your own local version of the main line and you've had it for a week, sitting nicely on your machine, but you haven't pushed, then that's not continuous integration. That's a branch by a sneaky back door. You're effectively in a branch. And this is what has started happening. People have, maybe we've got some new developers have joined the team who tend to be a little bit more worried, like, oh my God, I can't push my code to the main line. I'm going to break it. I'll just hoard it for a little while. I'll just kind of keep onto it. And if you're not pushing frequently, then when you do push, then it's going to have to merge with all of the other code that everybody else has pushed. You've got merge hell again. Like I said, you may as well have been working in a branch. So now what we have to talk about, which I mentioned briefly before, is what I like to call it, but you'll see it wasn't me that coined the phrase, but I like to call it MMMSS. So MMMSS stands for many more, I often get it the wrong way around, many more much smaller steps. And you'll see it all written out in the screen in a minute. So we're working in many more much smaller steps, which means that we're pushing frequently. We're pushing several times a day back into the main branch. So many more much smaller steps was a phrase that was coined by G. Paul Hill. If you haven't come across G. Paul Hill, he's amazing. Look him up. He's written loads. He's got loads of videos on his site. He's just fantastic. He's just a lovely guy. And he talks about many more much smaller steps. And he writes a lot about why it is such a good idea to do everything in as small steps as possible and what a difference it makes and how much more flexible you are when you do that. But it's a skill, being able to break not just your stories down into smaller stories, but break your work down, break your code down into tiny steps. So you just write a small test and a few lines of code and you make the test pass, and then you're ready to integrate. When you're refactoring, you just change a few lines of code and then you make sure the tests are passing. The smaller the steps, the better. And he can argue for it much more eloquently than me. And Trisha G says in her article about trunk-based development, integrating small changes regularly into your code is usually less painful than a big merge at the end of a longer period of time. I mean, it's not even that contentious, really. I mean, you can see that that would be the case. So I'm now going to call it continuous trunk-based development, because what I'm saying is you're working on the main line, but you are continuously pushing back to the remote version of the main line. But you will still occasionally have minor merge issues. You're still merging. You're still editing code that other people in the team are also editing. And there still will occasionally be times, I mean, ideally you're communicating with other members of your team and you're saying, I'm working on this class. Is anybody else working on it? Well, this is what I'm doing. And you're going to try and minimize the chance that there are merge issues, but it doesn't mean they don't happen. They will happen. But the great thing, so the team does encounter merge issues and they're like, but you said we wouldn't get merge issues if we did trunk-based development. And it's like, no, there's still going to sometimes be merge issues. But guess what? If you're working in tiny, tiny steps, let's say you've changed a few lines of code, or you made a small change, and then you merge and there's a merge problem, and then you're, oh God, I don't know how to fix this. You know what? You can just throw your changes away, pull the latest code and play your changes on top of it. That becomes a lot easier and less scary and less painful if you're working in tiny steps. So the smaller the steps are, the easier it is to just say, I'll just throw it away and start again. It's not a problem. So what about feature flags? So a lot of the time, people think that one way to handle not working in branches is to use feature flags instead. So we're all working in the same branch of the code, but I'm developing something that isn't really ready yet, that I don't want to appear on the front end, that I don't actually even really want to be mixed up with that feature over there because my feature's over here and it's a bit different. So I'm going to put a feature flag around it. And that feature flag, there's loads of really good systems for feature flags. They can be configurable. They can actually be configurable by people who aren't you. So testers configure them. Product owners can configure them. They can turn things on and off and say, what if this feature's on? What if it's off? But it can be dangerous. Again, it can be kind of branching by the back door, because what can happen with feature flags is that you're basically isolating your code from the rest of the code base, which means that you're not integrating it. So again, coming back to GPAW, he says, to get maximum bang for your trunk-based development buck, all developers all the time should be running with 100% of the features turned on. Doesn't mean that you shouldn't have the capacity to turn them on or off, particularly at the user interface end. I mean, you'll be working on features that you don't want your users to be using yet. That's fine. But beware of having feature flags working in such a way that the code is effectively not being integrated. So he says a great deal of the benefit of continuous integration and trunk-based development both is in the extensive pre-testing workout the code gets as it's used by the rest of your team. So because your code is being integrated with your colleagues' code, you'll find out if there are issues very quickly. Okay, conclusions. So this again was from my ex-colleagues, one of my ex-colleagues from ThoughtWorks. Eli says, we use branches, this is where they currently work. We use branches when we don't mob or when we modify shared code. So they are in the habit of using mob programming most of the time. Nobody likes it. Nobody likes using branches, which in turn encourages us to mob more. So it actually encourages more collaboration. And I'm not the boss of you. I'm not telling you what you should do. But Dave says any form of branching runs counter in principle to the ideas of continuous integration. He says, don't branch, don't branch, don't branch. I'm going to say there are lots of reasons why you might be branching. But just saying. So why does trunk-based development make things better? So the benefits of trunk-based development. So small steps is a good example of something that's both a precursor and an outcome of trunk-based development. You will get better at working in small steps if you do continuous integration. You get fast feedback. You find out very quickly whether your code is problematic or not. You avoid merge hell. You reduce risk because every change is small and easy to roll back, and any problems are also small. Faster integration, fewer queues, you're not waiting around for things to be merged. Collective ownership. You're working highly collaboratively. You know what your colleagues are doing because it's being merged in constantly. And ideally, you're doing it together. But if not, then you are going to have to be communicating very effectively with each other. And the code gets better as a result. There's tons of evidence via the DORA metrics and the State of DevOps reports. And the DORA report 2022 said trunk-based development has been shown for years to accelerate software delivery velocity. So here's a summary of the techniques that you will need to get good at in order to do trunk-based development. You can do some of these things without doing all of them. They will all give you benefits. So the first one is have automated incremental testing. So you want an automated pipeline that you know will fail if there are any problems with your integration. You want to minimize dependencies so that your builds are fast. You want to speed up your tests as well. And you want to keep the build green. You want that to be an absolute top priority from anyone on the team. If the build goes red, you fix it. Build and test on your own machine first before pushing to remote, but do push frequently. Use test-driven development. Refactor frequently. Throw things away. Don't be afraid to do that. Work in many more, much smaller steps. You might need help in order to develop the skills that you need in order to get good at this. You also need to build trust. You want to be able to trust each other, that you know that you can all write good code together, which then leads to high, strong collaboration. I put be patient there because you're not going to be able to most teams wouldn't be able to just suddenly start doing trunk-based development. You have to build the skills that you need over time. Interactive code reviews. So rather than code review being a passive process that's done where somebody writes some code and then somebody else on their own, without talking to the person that wrote the code, reviews it in isolation. Instead, talk to each other, do the code review with the person who wrote the code. And if you have all of that in place, then maybe you can avoid branches and ditch pull requests altogether. Okay, so there's tons of links. I'm assuming there'll be some way for me to share these slides, but I will, they're already online somewhere, but I will, if you keep an eye on my social media. But I think the organisers probably make a way for that to happen. There's a bunch of links here of the things that I've talked about. Here are some more, loads of links. Dave Farley's got a lot of really interesting stuff to say about trunk-based development and also compliance. And this is a podcast that I hosted that you might be interested in. And this is my piece on trunk-based development. So it's everything I said today and more. It was published by O'Reilly last year. And this is me. And the QR code should help you to get everything else, because I've realized that tiny URL links don't actually work for everybody. Okay, are there any questions? We've got 4 minutes. Yeah.
You mentioned about the huge pull request, and I think we all know that it's a huge problem because, as you mentioned, it's harder to review and to kind of you gave all those changes. How you guarantee, like, if you have the integration, but let's say you can't do the pair programming, for example, how you guarantee that it won't be the same problem with the merging back to the trunk if you are not doing the pair programming, for example?
Okay, so you said that we all recognize that those big pull requests are problematic, but if you're not doing pair programming, how can you be sure that you're not going to have problems? So if you don't do code reviews. So this is why I wouldn't just say ditch code reviews, and that's why I said at the very end of the list, ditch PRs. So that was after you do have pair programming, or you're highly collaborative, or you have collaborative ways of reviewing code. But ideally, pair programming, you're working in tiny steps as well. So every change is small. So that reduces, again, the risk that something is going to cause a problem. So if you did have PRs, they would be tiny. It would be like just this tiny change and then another tiny change and then another tiny change, which actually, would become tiresome. Instead, what you do is you trust that because there is a high degree of collaboration when the code is being written, because the changes that are being made are very small, because they were always surrounded by tests because the tests were written first, because you have an automated pipeline with tests built in. So because you've got all of these other processes in place, then you can have confidence that the code that is being pushed into the main line is not that it's never going to be problematic, but any problems it introduces are likely to be small.
Thank you.
Thank you for the talk. What relation does do these tiny changes have to the actual requirements that we get to implement?
Yeah, so I'm not saying ditch tickets. So like you could be working, I would absolutely recommend that you get really good at slicing your stories as small as possible, but you're still going to be working to a requirement of some kind or other. There's depending on your workflow, but there will be somewhere there will be some description of what it is that you're doing. And that's fine. So a lot of people do have a problem with this because they think, yes, but what happens is I work on a JIRA ticket and when I'm done, there's a pull request and the pull request is attached to the JIRA ticket and that's the proof that the thing is done and then it gets merged and that's the end of that. It doesn't have to be the end of that. There can be other ways of ending it. So you can say, I'm working on this ticket. You might want to, for instance, tag all of your commits with some relevant ID. You might not. That might not help. But you can when you're done, you can get together testers, product owners, anybody who has an interest and say, let me show you what I've done. And they can say, yes, that's what I wanted you to do. Or they can say, nope, that's not right. And you might have to go back to the drawing board. But there's nothing, that doesn't have to involve a PR. People think it does because that's how they're used to working, but it doesn't have to involve a PR. It can just simply be a question of saying, and I've worked in many teams that do this, and it's just like, we finished the work, we're going to get a bunch of people together who have an interest, we're going to demonstrate what we've done, and actually, again, we won't do that at the end of the process, only at the end of the process either. We'll be constantly having conversations with anybody who has an interest and saying, oh, come and have a look at this thing I've done, come and have a look at this, so that when they see it at the end, it's not a surprise because they've been involved in the whole process all the way through anyway. Okay. Officially, time is up. So if you want to ask me anything else, come and find me. Thank you.